Okay, welcome everyone. Also from my point, I'm happy to be able to share my research on Sudbury here with you today. And we've heard quite a bit about the sulfides associated with the SHC so far, and I want to focus on the melt sheet itself in this short presentation on the main mass, which, as you can see down here, is generally composed of a lower noritic unit. Then we have this thin quartz gabbroic transition zone, and then a thick upper granophyre. I want to look at the main mass because both the main mass and the sulfide ores are part of the same large system triggered by this impact event. And as such, if we want to understand the formation of the sulfides, we also have to understand the differentiation history of the melt sheet itself of the main mass. So there are a few models out there that try to explain the evolution of the main mass. There's one by Desereau, who proposed a bottom-up and a top-down crystallization of a single impact melt. And then on the other side, we have Golightly and Siegentmarsh, and they both proposed a post-impact segregation of this impact melt into an upper felsic and a lower mafic member, which then crystallized to form the norite and the granophyre. So what I want to do as part of my project is I want to test these models. I want to look at the geochemistry, mineralogy, petrography, and the isotopic composition of the main mass to see if it really is a uniform mass or are there local differences, and if there are, how these local differences might affect or have an influence on the formation of sulfides. So in terms of sampling for this purpose, I'll be focusing on the North Range here, and highlighted in yellow are traverses through the main mass that I either have collected or that I'm in the process of collecting at the moment. And then green stars here, they indicate historic traverses that I took from the literature. For this talk, I'll just be showing a few plots from the two Cascaden traverses here, Cascaden 1 and 2, for the Morgan traverse here, and then the green Capriol Mac 91 traverse. You can see them on the right here. And as you can see, the total thickness of the main mass varies quite significantly along strike. And I'll come back to that in a minute, so just keep that in mind as we move on to the first element. And I want to start with MgO variations through the stratigraphy. And what I did here is I normalized the four traverses to a specific horizon so that we can compare them next to each other and see the same units here next to each other. And I'll just briefly go through here and try to highlight some interesting differences that we can see and try to give an interpretation of that, keeping in mind that that's based on a geochemistry, and as I move on and do more petrography and mineral chemistry, that some of this might obviously change. So starting at the bottom, we can see here in Capriol, we have these pretty high or relatively high MgO contents at the base, and they reflect the accumulation of cumulus orthopyroxene forming this mafic norite unit here. We can see a similar thing, although not to the same extent, also in Cascaden 1, slight increase, slightly more OPX. And then interestingly, just a few kilometers away, Cascaden 2 shows this the opposite, this basal reversal to slightly lower MgO at the base. As you move up then through the stratigraphy, an interesting thing here in Cascaden 2 is this zigzag pattern, which potentially could represent some sort of magmatic cyclicity in this part of the melt sheet. And then as we move further up through the quartz gabbro and into the granophyre, one interesting thing here is, if we look at Capriol, we have this indication of a downward crystallization trend from higher to lower MgO. And then if we look at Cascaden, for example, we see the opposite of a clear upward crystallization. Next one, calcium. And the main thing I want to point out here is after this relatively smooth upward trend through the lower felsic norite, we have this sudden jump and increase in calcium in both the Cascaden traverses and Capriol, and also again some sort of magmatic cyclicity, which is very different to the Morgan traverse, which shows this relatively smooth upward crystallization trend. And that's interesting because the major minerals in these rocks are all the same, so that indicates these differences, that the proportions of these minerals crystallizing or accumulating are probably different. And just to further illustrate, just the last slide here, or the last plot, to look at it in a bivariate plot, we can see MgO versus calcium here in the Cascaden group, we see the two felsic norite and quartz gabbro forming two distinct groups and trends. Same thing for Morgan. And then if we think about which minerals might control this, we have OPX and plagioclase controlling the trend here for the felsic norites. Then we reach CPX, which is the liquidus, and we get this accumulation of CPX and plagioclase forming this increase in calcium. Then we move down this catectic line here for the quartz gabbros. If we look at Morgan, very similar minerals controlling the trends, but rather than having this jump in calcium, we see this inflection point, and that might indicate that rather than accumulating in this CPX in this section, we might just have a more or less continuous fractional crystallization trend. And that's obviously something I have to follow up on with petrography and see if that's supported by it or not. So just to conclude, just from these few elements, we can see that the differentiation history is not as uniform as we would think in the main mass. There's quite a bit of variation, especially in terms of minerals being accumulated in the different sections of the melt sheet. And also interesting is that thicker sections like Capriol and Cascaden seem to be more complex, and thinner sections like Morgan seem to be more behaved and less complex. And a possible idea, just to throw that out here, is that maybe these thicker sections represent more dynamic environments within the melt sheet during crystallization, which then form these more complex patterns. So yeah, that's it from me. Thanks for listening. Feel free to ask any questions or send me an email later if you have any questions or want to know more about it. Thanks.